Hello boys and girls, Mr. Jamini. Want to talk to you about a little bit about writing and graphing inequalities. Now, let's first of all talk what is an inequality. Well, an inequality is a relation between two expressions that are not equal, employing a sign such as, here you see the not equal to sign. That's a little symbol that recognizes or indicates to us that two things are not equal, two expressions are not equal. Here we have greater than, so something is greater than something else. We have the less than, something is less than something else. Here we have something new probably. Greater than, and you see it's underlined. Greater than, and that means greater than or equal to. And you see that little underline, if you think about it, it's like an equal sign, but half of an equal sign, because the top part is greater than, the bottom part would be equal to. So a number is either greater than or equal to this. So here's an idea. X, which is one expression, is greater than or equal to 50. Now, this has several different answers in the solution set, as do the other two I discussed up here. We'll get to that in a little bit. So if I want to think about this, X is greater than or equal to 50. So if I want to think about numbers that would make this inequality true, let's think about a number that's greater than 50. Well, I could say 60. I could say what else? What's a number that's greater? Excuse me. What's another number that's greater than or equal to 50? How about 78? About 107? What about 50? Does 50 make that inequality true? Yes, it does, because 50 is greater than or equal to 50. That's just some of the numbers in the solution set. Now, if I go over here, now we have this symbol. This is less than or equal to. So something is less than or equal to something else. So this part of the expression is less than or equal to 50. So if I want to think about it, I could say 7. That is less than or equal to 50. I could say -8. I could say 0. Can I say 50? Is 50 less than or equal to 50? Yes, it is. It's equal to. So you could see when I have that equal to, I can use that number on the other part of the expression to make the inequality true. When I don't have that equal to, I can't. So for instance, for something like this, I would say, hey, X is greater than 10. I could put a bunch of answers that are all larger than 10, like 11, 28, 96. But could I put in 10? Is 10 greater than 10? No, it's not. So I wouldn't have 10 in this solution set. And again, with this one, X is going to be less than 10. So this side of the expression, this side of the inequality, this expression is less than this expression. Numbers that would make this work would be something like 9 or 0 or -92. Would 10 make this inequality true? No, it wouldn't. So I cannot use 10 as part of the numbers in my solution set. Now, if we talk about reading some inequalities or writing inequalities that match a given scenario. So let's take a look here. It says choose, there's my verb, choose an inequality for each situation. So we have X is greater than 10, X is greater than or equal to 10, X is less than 10, or X is less than or equal to 10. So the temperature today will be at the very least 10 degrees. So that means the temperature, and we'll use X, that's what we're using. So at the very least, it's going to be 10. So there's the other side of my inequality. Now, if something's I have at least $5 in my pocket. That means I could have 10, I could have 20, I could have 30, I could also have 5. So that means I could have more than 10, or it could be more than 10 degrees, but at the very least, it could also be 10. So that means X is greater than or equal to 10. Let's take a look at the next one. The temperature tomorrow will be no more than 10. So I have no more than $100. If I have no more than $100, I can't have 105, but I can't have 85. I can't have 180, but I can't have 10. I can't have any more than 100. So looking at this one, the temperature can be no more than 10, but it can be equal to 10. So that means it could be less than or equal to 10. Next one. Yesterday there was less than 10 inches of snow. Well, that's not bad. X has to be oops, I was almost going to put greater than. It's that easy to make a mistake. X is going to be less than 10. And then finally, last Wednesday there was more than 10 inches of snow. More than, so it'd be X is more than 10. Now 10 would not make this true. 10 is not more than 10. So that's why we don't have it underlined. Now, sometimes we also graph inequalities. It says complete the graph for each inequality. Now, they started it for us. Now, if I want to read this, it says A is greater than 3. And notice what they did here. At the 3, they put an open circle on the 3. That's because the solution set would start at 3, but does not include 3, because 3 is not greater than 3. But 3 and 1/10 is, or 3 and 5/100 is. Now I need to say, this is not done yet. I need to graph it. Which direction would other numbers that make this solution set go in? Would they go to the right of 3 or to the left of 3? So A is greater than 3. All numbers greater than 3 go to the right. So that's how I graph that inequality. Now this says R is less than or equal to -2. Now notice, it's a closed circle because -2 is included. -2 makes this inequality true. So -2 is less than or equal to -2. But now it says less than. So where are the numbers that are less than -2? To the right or to the left? -1, 0, 1, 2, 8. 2 is greater than -2. Oh, so we're going to go to the left because -3 is less than -2. So, but it's filled in because it's equal to. All right, and one last one here. Here's a simple one. Mr. Giomini is greater than or equal to Mr. Peltz. That's how you just read that one. Notice the inequality symbol I used. This is one side of the expression. This is one side of the inequality. Mr. Giomini is one expression. Mr. Peltz is another one. Mr. Giomini is greater than him, or he's also equal to him. I'll let you be the decision. I'll let you decide that. All right, hope this helps. Take care. Bye-bye.